In this course, we are going to solve a problem on general bearing with L by D is equal to 1 and a century ratio of 0.25. And in this slide, you can see the bearing geometry, bearing meshing, and also some results. But before that, let me give you some idea about the bearings. So if we go through this word file, so let me explain that what is the meaning of the definition of different terms. So the first of all, the bearings are used for allowing the friction, free motion or with a very less friction, and it also allows the motion in the one direction and restricts the motion in other directions. And also the bearings also used for support the shaft. So for example, if the shaft is very long, so in that case also we use bearings to support the shaft and to allow the rotation of the shaft. The definitely bearing is moving from the inside. So outside is stationary in most of cases, inside is moving with the shaft. And the examples you can see about the bearings, you can see them in car engines, airplanes, generators, even in the sliding doors in your home. The bearings are of various types, but the well-known or common bearings you have heard is ball bearing, the roller bearing, and also the plain bearing, that is also known as general bearing. But I will describe them one by one, and also sometimes what happens is that the one type of the bearing is also overlapping the other types of the bearing. So just go through them as it is they are. So in the ball bearing and roller bearing, difference is that in the case of ball bearings, we have the spherical balls. They are put around the circumference of the geometry. Inside is rotating and outside is stationary. And in the case of rollers, they are cylindrical bodies. They are cylindrical bodies. The only difference is this one. So so they are almost same in the appearance, and one has a cylindrical. So the one has the cylindrical appearance and second has the spherical or the ball. So this is not about the outer appearance, but it is from the inside. And the another difference, you can see the ball bearings, they are sold as a complete assembly and they are replaced as it is. So you have to replace the whole bearing with a new one. So that is what it is replaced as a full unit. And the ball bearings are used for the higher speed machines, but with the lighter loads than the roller bearings. And but in the case of when we have the shocks or the impact loading, the roller bearings are the preferred choices. And another difference is that the ball bearing are a lot noisier than the ball bearings. So if you want to reduce the noise, then and the load is lighter, then the choice would be the ball bearings. And also the examples I want to give you is that the ball bearings, you can see they are used in the skateboards. That's a sport thing. In the blenders, in the bicycles, and also photocopier machines. And the roller bearings, they are used in the automotive such as wheels, transmission, and they are also used in the conveyors, fans, pumps, and gearboxes. And now we are going to discuss about the linear bearings. So as you can see, the name suggests that the linear bearing allows the motion only in the one direction, that is the linear motion, not the circular motion. So again, we have the simple, like we have the balls here, and these balls, when we slide them, they present the less friction. But the only thing is that the motion is linear one. And you can see the use of linear bearings in the sliding doors or the drawers. And these are the two figures for the ball bearings and the roller bearings, so you can get the proper idea about these two type of the bearings. Okay, then we have the dual bearings. Dual bearings basically, as the name suggests, they are used in the some sort of jewelries. So they are used where the machine is very small and it requires a very high precision movement, such as in the watches. And they are also not built from the simple material like the iron, steel, or other metals, but they are built from the precious materials. You can search on the from the books or from the Google. And these are some designs for the jewel bearing. We have the roller jewel, the hole jewel, pellet jewel, and the cap jewel. Okay, now next type is the magnetic bearings, and it is a type of bearing that supports load using the magnetic levitation. Levitation means that it creates the difference between the two similar poles, so that we have some gap between the bottom surface, that is the ground, and the upper surface, that is the bottom of the train. So in this way, basically what happens is that there is only resistance which we are going to experience in the train movement is the resistance. Otherwise, the other all sliding resistance, or other resistance or frictions, they are nil. So and they are used for the high speed trains, and there's no speed limit for the bearings as far as they are concerned. Definitely we have the speed limits for the trains, and definitely when there is no contact between the two surfaces, they are quieter, and also they don't require the lubrication. And now we come to the plain bearings. Plain bearings are simple in design, so it is like two concentric cylinders. And they can also be of different shapes, not only the cylindrical shapes. They can also be tandem. They have some slight change in the radius along the length. So they are very simple in design. They don't contain any rolling elements, and they work on sliding friction mechanism. And they are quieter than the anti-friction bearings, such as the roller bearing and the ball bearing. And since they don't have any moving parts like the balls or the rollers, so therefore they have the less friction, and as well as they are quieter. And the main example you can see for general bearings is the plain bearing. And another example you can see is the furniture drawers. And they are also sometimes, some of them also called the thin film bearings, general bearing, hydrostatic bearing, hydrodynamic bearing, etc. And now we come to the main bearings, which we are basically going to solve in this CFD exercise or the course or the workshop. So the fluid bearings are the bearings in which the load is supported by a very thin layer of pressurized fluid film. That pressurized fluid film basically is responsible for making the distance between the two surfaces. And because of the oil, so we have the only friction due to the oil. So it has the very less frictions compared to other bearing types, and also they are more quieter. Definitely they are not more quieter and the less friction or frictionless as compared to the magnetic bearings, but they are the best among the other bearings. And they are further divided into the hydrostatic and hydrodynamic. And you can see the name. Hydrostatic means that we have some static pressure, and dynamic means that the pressure is developed because of some motion. So hydrostatic bearings are the bearings in which a lubricant is pumped into a bearing at high pressure to keep the constant clearance between two parts. Okay, so you can see the figure here. So we have the lubricating oil here in some reservoir. We have the pump, and we have to pump the oil at the constant pressure depending on the loading capacity of the bearing. So if there is more load, so the pump should be pumping at the high pressure and with the more lubricating oil. And they are used in the guideways, spindles, turntables, and space telescopes. Second type is the hydrodynamic bearing. These are the most important bearings you will see in the many applications. And in these bearing, rotation induced lubricant into bearing. So what is happening here is that because of rotation, it sucks the working fluid or the lubricant into the bearing from some oil reservoir. And because of the motion of the journal, so journal is name used for the inner part which is connected to the shaft, and the bearing is the outer part or the sleeve which is stationary. So because of the motion, what happens is that it sucks the oil into there, and also it does not have the concentric formation like in the hydrostatic bearing. So you can see that we have the minimum thickness of the film on some location, maximum on the other side, and then the constant on the two sides over here, and it creates a wedge from all sides. So definitely we have the high pressure at this point. And this pressure basically the highest pressure is not over here, but high pressure is before the minimum thickness, and it is in direction of the rotation of the shaft. It is somewhere here. And after this point, what happens is that the pressure will start to reduce to the zero. So in the case of the because of there are some fluid mechanics things are happening there. So in a very simple sense, after this point, the pressure should be negative. That is the below than the atmospheric pressure, that is known as cavitation. But this not happens in the case of the aisle. So what happens that the pressure on this side is zero, and then again from, if you take the minimum thickness here, so draw a line, straight line that is connecting the two centers. So on this side the pressure will start to build up. So, and this is the mechanism that is basically supporting the shaft with the help of the opposite bearing pressure. And so as you see that they are used in the steam turbines, electric motors, automobile engines, various parts in the crankshaft, various things, pumps, blowers, etc. Okay, now come back to the slides here. So basically the problem we are solving here is the journal bearing. And journal bearing is the type of the hydrodynamic bearing, and they consist of the shaft or journal, which is the inside part, and also we have that rotates freely in the supporting metal sleeve or shell or the bearing. And as I told you, this is the sort of the it is certain hydrodynamic bearing, and its main function is support the rotating shafts such as the engine or the powertrains. And you can see them in the crankshaft and the camshaft if you're talking about the internal combustion engines. And here you can see that we have the main bearings here, and then we have the connecting rod bearings over here. Okay, main bearings are over here, they are supporting the main load. And then crankshaft bearings are, which are connecting rod bearings, which are here, and they are connected to the crankshaft. And also we have the camshaft bearings, which are, you can see over them over here. Okay, so the crankshaft bearings, they are called the main bearings, and general bearings are also used for the connecting rods and the camshaft. Okay, so now we are talking about the basics of the general bearings. So I'll discuss this thing in the next lecture. So I will stop here. So I've just gave you the oral introduction of the bearings and what we are going to do in this course of the workshop.